Hey everybody, this is Matt with mathsmath.com. Thanks for joining us here today as we talk about sine and cosine ratios. We're in the Math Common Core standard of the number system, and we're going to be working with right triangle relationships today. Alright, our guiding question and our goal today is we're going to use sine and cosine ratios to find the angle of a right triangle, as well as measurements, unknown measurements in those right triangles, okay? So with sine and cosine ratios, what we're looking at is this unique way in order to find the length of a particular piece of a triangle, a right triangle, or an angle. It's a pretty cool thing to think about. If you think about a football field, you got a football, you want to kick it at a specific angle, use a right triangle, and bam, there you go. Well, we've used the Pythagorean theorem in the past, but another special way to use with right triangles is comparing the side lengths. When we compare them, you will notice over and over again that particular ratios are formed. And that's what mathematicians and throughout the whole past have looked at, is they found these ratios over and over again. This is a branch of math called trigonometry. Well, if you know the angle of a particular piece of that triangle, not the 90-degree angle, but the other two, you can find the length, the adjacent, the opposite, or the hypotenuse in that triangle. And using these ratios, they're called sine and cosine. So let's look at those. The sine ratio, okay? The sine ratio is the ratio of the opposite leg to the hypotenuse from whichever angle you're at. So if you're at angle E, the opposite leg of E is A, and the leg next to that would be the adjacent one, but we're not going to worry about that, okay? It's the angle, the sine of angle E is the opposite, so it's A compared with the hypotenuse, C. We would write it like this. Sine of the x is the sine of the x degrees equals the opposite over the hypotenuse. It's a ratio. You're just comparing them. You put the length of A over the length of C, and that gives you the ratio of the sine of x. So the sine of E is A over C, right? The sine of D is you take the leg opposite, which is B, and compare it to C. It's B over C. The sine of F is C over C. Don't really worry about that. And that's it, okay? Now, the other way to do it is the cosine. The cosine is the ratio not of the opposite leg, but of the adjacent leg of the hypotenuse. So here, for example, if we do the cosine of angle E, it's the leg adjacent, which would be B, compared to the hypotenuse, which is C. If we did the ratio of the cosine D, it would be A compared to C. Let's put it in this way. Cosine of x equals adjacent over the hypotenuse. And if we did the cosine of angle D, we get A over C. Again, A is adjacent to D, and C is the hypotenuse. Cosine of E is B over C, and the cosine of F, well, C over C. Can't really do that, okay? So we don't really talk about the cosine of F. We don't do anything really with that right angle. We're only looking at angle D and angle E, okay? All right, so let's write the ratio of these trigonomic functions. So let's talk about this one. All right, we've got this triangle. Let's talk about what is the sine of angle P. Remember, sine is the opposite of that angle, so it's 15 compared to the hypotenuse. So we're going to write sine of P equals the leg opposite of P over the hypotenuse, and it's 15 over 17. If we divide that out, use our calculator, we'll get 0.88. So sine, if we were to hit now the sine of that angle, it would give us 0.88. That's our ratio. Okay, let's do the cosine of angle P. Let's do the cosine of angle P. Remember, cosine is taking that angle and doing the adjacent compared to the hypotenuse. So now, the adjacent of P compared to the hypotenuse, it's that fraction, equals 8 over 17, which is about 0.47. Okay, that's the ratio. It's that angle. It's the cosine of that angle. All right, so now I want you to do these on your own. Would you tell me what is the sine of R? Now notice I haven't really talked about this, but sine you abbreviate it as sin. Okay, you take off the E, and cosine is COS. So please tell me, what is the sine of angle R? What are the two numbers you're going to stack up to each other, and what would be the decimal? All right, remember, sine is opposite over hypotenuse. Okay. Opposite over hypotenuse, 8 over 17, which is 0.47. Notice that that's what was before for the cosine of the other angle. There's a lot of coincidences here. Now do this, cosine of R. I bet you can think that if the sine of R is the cosine of the other angle, cosine of R might be something related to the other guys. Well, 15 over 17, 0.88, exactly, all right? There's a lot of relationships here. All right, let's look at these. What are these ratios? Cosine of K. Cosine of K. K is the adjacent over the hypotenuse. Sine of K is the opposite over hypotenuse. Sine of L is the opposite over hypotenuse. Cosine of L is the adjacent over the hypotenuse. Notice anything there? Should be noticing some patterns there when you switch the angles and the cosine and the sine. Right. If you know the sine of one of the acute angles, how can you know what the cosine is of the other acute angle? That's the pattern. That's the pattern. If you know the sine of one of the angles, you know that that's the cosine of the other angle. Pretty cool. You ever think that sine or cosine of an angle can be greater than 1? Any thoughts on that? Maybe plug it into your calculator and see if you can ever get anything that's greater than 1. All right. So the safest angle of a ladder that can be placed upright is 75 degrees. You don't want to put a ladder that's at 85, 90, all those kind of things, okay? Well, you have a 12-foot ladder here. What's the highest point on a building that the ladder can lean up against? Now, you have a 12-foot ladder. That doesn't mean it can go up 12 feet on the wall, okay? Here's your diagram. It's got to go up 12 feet this way. So if we're going to write this, I want to talk about specific sine or cosine ratios. What would I be using in order to find x here? Would I use cosine or would I use sine? All right, we're going to use sine because it's the opposite of the angle compared to the hypotenuse. So here's how we write it. We write sine of 75 equals the opposite, which is x, over the hypotenuse, which is 12. Okay, we write it just like that. Now, notice here we're cross multiplying 12 times the sine of 75, okay, in order to find x there. Get rid of that 12 on the bottom, multiply it by the other side. So on your calculator, what you can do is simply just put sine of 75 and then multiply that by 12. And that gives us about 11.6 feet. So what we're saying here is that ladder, even though it's 12 feet, can only go up 11.6 feet on that wall at its most crucial angle of 75 degrees. How could you use cosine to find the maximum height of the building that you would be climbing the ladder up? Could you use cosine? You could, but you have to find that angle right there. All right. Kind of get the hang of it? This is something that's completely different than most likely you have ever done before, having this random weird word tacked on to these angles, like sine or cosine. We'll keep working with it, okay? What if it was a 20-foot ladder? I want you to do the same thing except with 20-foot ladder. How tall would it be? Again, use that sine of that specific angle, cross multiply, tell me how tall the building would be, how high that ladder could go up. All right, here we go. Sine of 75 equals x over 20. X is about 19.3 feet. Sometimes, just a quick note here, you might need to put sine of 75 in first before you put in, say, 20. 20 times the sine of 75 might give you something different. So I would recommend always putting in the ratio here. So put sine of 75 in, hit equals, and then multiply it by the other number, okay? All right. Well, wheelchair ramps have an incline of 4 degrees, okay? If the ramp is 366 inches away from the end of the ramp, the beginning of the ramp is that far away from the end of the ramp, what is the actual distance traveled on the ramp? What's the height of the ramp? You might want to draw a diagram in order to see exactly what we're talking about here. All right, did you get something like this? It's 366 inches from beginning to end. It's 4 degrees. What's the height of the ramp? Are we using sine or cosine? What's the length that the person would travel on the ramp? Are we using sine or cosine? All right, well, let's use cosine. If we take the cosine of 4 and we have 366 as the adjacent, we want to try and find the hypotenuse here. All right, let's try and find x. Notice here what we're going to do is we're just basically going to flip-flop the cosine of 4 and put it in its place of x and put x on the other side. If we cross multiply, that gets us x times cosine of 4. Then we have to divide by the cosine of 4. So just a little trick here is you just take 366 and divide it by the cosine of 4, and that gives you x. With the 4-degree angle, it's not that much different, is it? It's only about 1 inch longer. Why is that? Maybe because the angle's so small, huh? Well, now let's try and find y. Let's think about y. What's the height of the ramp? Why don't you do that on your own? Is that sine or cosine? All right, it's going to be sine, and it's the sine of 4. Now, we have the hypotenuse, which is 366.9. So sine of 4 times the hypotenuse gives you 25.5 inches. So even though that angle is so small, the ramp is about 2 feet. Okay, it's 2 feet tall. Pretty cool what you can do with these ratios, huh? Sine and cosine will really change the way we look at math from here on out, especially with right triangles. They're very neat. All right, well, that was it as we talked about it. Think about the angle here of this football, the angle that it has to be kicked. Just fly in the air there over the goal. Pretty cool. All right, well, this was Matt with mathsmath.com. Thanks for joining us here today. Check us out on Facebook at Solving Maths Problems and on Twitter at Maths Math. And enjoy math.